What is the definition? Let me see. Now, whichever the properties, whatever it may be, the which depends upon the properties which depends upon number of solute particles. Understood? The particles which depends upon number of solute particles here. That properties can be called colligative properties. Understood? The properties of dilute solutions. Generally, what happens in this case, whenever we are discussing the colligative properties, okay, we have to take which solutions, beta? Dilute solutions we have to take. Okay, whenever we are discussing colligative properties, we cannot take concentrated solutions. What type of solutions we have to take here? Dilute solutions. Now, in this case, whichever the properties they depend on, they're depending on the number of solute particles, the number of solute particles, otherwise the number of particles of the solute, okay, the number of particles of the solute, otherwise solute particles. The particle may be ions like Na plus, isn't it? Cl minus, maybe molecules also. Molecule means what? Something like glucose like this, C6H12O6, like that. So its definition is very simple, but very simple. The definition is very, very simple. The properties of dilute solutions which depend upon the number of particles of solute present in the solution are called what? Colligative properties, isn't it? Colligative means what? Together. Nothing but together, actually. Right? So again, I'm saying this definition. So we have to take dilute solution. In the dilute solution, okay, whatever the properties, isn't it, which are depending on how many number of solute particles you're having in the solution, then, isn't it, their properties are called colligative properties, because this is very, very important definition. Better. Next, let's see the what are the properties we're having. Colligative properties. Which properties are now have taken as the colligative property? First of all, relative lowering of vapor pressure. Relative lowering of vapor pressure is called colligative property. Second, elevation of boiling point is a colligative property. Third one, depression in the freezing point is a colligative property. Fourth one, osmotic pressure is a colligative property. Osmotic pressure can be represented by pi. Depression in freezing point represented by delta TF. F for what? Freezing. Elevation in the boiling point can be shown by delta TB. B for what? Boiling point. And relative lowering of vapor pressure, isn't it, can be shown by what? Delta B by R, that we'll discuss when we derive what? Derivations for this. Now, so these four are what? Colligative properties. Understood? Now, boiling point, is it called colligative property, beta? Anybody? Is boiling point is called colligative property? Anybody?
No.
Now remember, freezing point, boiling point, vapor pressure, they cannot be called colligative properties. Elevation of boiling point, depression in freezing point, is an osmotic pressure, relative lowering of vapor pressure. These can be considered as a colligative properties, because this question many number of times which was asked in examinations. Understood here? So that is the reason what happened. Remember, isn't it? Always colligative properties are four only. What are they? You practice that. Now, for example, if you observe, one formula weight NaCl is a solute I have taken, and one more I have taken glucose I have taken. So two solutes I have taken in the different solution. This is one solution, solution 1, solution 2. Now, when NaCl dissolved in the 1000 ml, we get first solution. When glucose is dissolved in 1000 ml, we get the second solution. Separately, we are mixing them. So we got two solutions there, two different solutions. One is NaCl aqueous solution, other is glucose aqueous solution. Now, which solution experience more colligative property? Which solution experience more colligative property? See, colligative properties depends upon the number of solute particles. It depends upon, just now I told you, it depends upon number of solute particles. Now, in which case you are having more number of solute particles? Which case you are having more number of solute particles? Sodium chloride or glucose? Vanita, can you say answer for this one?
Sir, sodium chloride.
Why beta? Because it has how many particles beta?
Because it is ionizable and it has two particles.
Cl minus. So it will dissociate into two particles. When you dissolve NaCl in the water, it will dissociate into two particles. But glucose C6H12, even though if you dissociate, even though if you dissolve in the water, it never dissociate. So it will be only one particle. It is only one particle. And this one will be two particles. Right? So it depends upon the after dissociation, how many ions we are going to get. The sum of what? Both cations and anions you have to consider here. Right? So one molecule or one formula unit of NaCl produce two ions after dissociation. By glucose does not dissociate. Glucose does not dissociate into ions. Hence, it remains as a one particle. Therefore, the solution containing NaCl experience more colligative property. Understood? Now, can you give answer for this one, beta? Tell me the answer for this one.
Osmotic pressure.
Boiling point, freezing point, vapor pressure, they are actually what? Only their properties, physical properties they are actually. They can be measured for what? Solutions physical properties. But colligative properties depends upon what? Number of particles. Here, boiling point, freezing point, vapor pressure, they don't depend upon the what type of particles you are having. See, osmotic pressure is the, isn't it? Colligative. Now let me discuss first one, colligative property. Let me start now here. First one, first colligative property, let me take. Now this is the first colligative property which I have taken. Relative lowering of vapor pressure, and we see some limitations also in that. Relative lowering of vapor pressure. Now what is meaning of this relative lowering of vapor pressure? So first of all, we'll discuss about lowering of vapor pressure. Then we'll start what? Relative lowering of vapor pressure. Understood better? First we'll start lowering of vapor pressure. Then we'll start relative lowering of vapor. First we'll see the definition of lowering of vapor pressure. Now what I'm doing here, I have taken a solvent better. I have taken a solvent. This is a solvent, right? Which type of solvent it is? Volatile solvent. Volatile component. Volatile solvent means beta, anybody knows what is the meaning of volatile? What is the meaning of volatile solvent?
Which evaporates.
Yes, beta. It will evaporates, right? Volatile will undergo evaporation. Water undergo evaporation. Like example is water. Water undergo evaporation. Now, I am adding a solute to this one. Which one? Non-volatile solvent. Solute. Non-volatile solute I am adding here. To the volatile solvent, we are adding non-volatile solute. Added to pure solvent. The solvent is volatile, which is a pure solvent. Only water only it is. To that water, we are adding a non-volatile solute. Maybe NaCl. I am adding, isn't it? It's a non-volatile solute. Now, what happens here? The surface area of, isn't it, solvent occupied by, isn't it, solute particles. Correct or not? Now, previously it looks like this. Previously, the solvent looks like this. Now, Definitely it is a volatile. Okay, it's a volatile. Now, whatever the molecules or atoms, particles, they undergo evaporation like this. They undergo evaporation like all the surface molecules, all the surface particles will undergo evaporation. Now you get a vapor here. You are getting a vapor here. Now this vapor you are calling as a vapor pressure. The pressure exerted by these vapor molecules you are calling as a vapor pressure. Vapor pressure here. Understood better? The pressure exerted by these vapor molecules, okay, this one, these vapor molecules is called what? Vapor pressure. At atmosphere pressure, they are called vapor pressure. But when you add non-volatile solute, the number of particles which are evaporating now becomes less or more when you compare with this first one. When you compare this one, first one.
Less.
Now we get here less vapors we get here. Less vapors we get. Now, when you get less vapor, definitely the vapor pressure also will be less vapor pressure. Here it will be what? More vapor pressure. That means what is happening here? When you add a solute, which is non-volatile solute, to a volatile pure solvent, the vapor pressure of the, isn't it, solvent decreases. This decreasing you are calling as lowering in vapor pressure. Lowering in vapor pressure. Understood beta? All of you?
Yes, sir.
Based on this water. This is solvent beta. This is solvent, no? This is solvent. I am writing the first one as a solvent. So vapor pressure of the solvent I am writing as a P naught beta. Okay? Put here P naught. Okay? Vapor pressure of this P naught is equal to nothing but vapor pressure of pure solvent. Pure solvent it is. Now this is called vapor pressure of what? Solution. Vapor pressure of solution, I am calling this one as P actually. Small p only, both are small p only. Both are what? Small p. P naught is vapor pressure of the solvent, where P is what? Vapor pressure of the solution. Now definitely what happened? P definitely will be lesser than what? P naught. Correct or not? Because P naught is vapor pressure of the solvency. The vapor pressure of the solution is always less than what? Vapor pressure of the solvent. Why? Because this is the reason. Why? Because the surface area of the pure solvent occupied by non-volatile solutes. I think everyone understood what is lowering of vapor pressure, right? Now I'm just roughing this one, whatever I written. Just removing this one, everything. Now we'll take some formulas also. Now P naught means definitely beta, this P naught is what? Vapor pressure of the pure solvent. When you write here P naught, one leave it that one. One is not first component maybe. Okay. This is what? Vapor pressure of the solution. Correct or not? So this you are to take. Okay. This you are to take. Vapor pressure of the solvent, vapor pressure of the solution. A lowering of vapor pressure is equal to what? Vapor pressure of solvent minus, isn't it? Vapor pressure of solvent minus vapor pressure of what? Solution. This we can write as delta P. Now delta P indicates what beta? Delta P is nothing but lowering of vapor pressure, or lowering in vapor pressure is nothing but what? Delta P. How much is decreased? Before, the solvent vapor pressure is 760 mm pressure. After addition of solute, the solvent got 740 mm pressure. The solution got 740 mm pressure here. Now what is the lowering of vapor pressure? 20 mm is the lowering of vapor pressure. So this is about the lowering pressure actually. Next. You already know this one, Raoult's law. Everyone knows, I think. What is Raoult's law means? The partial pressure of a liquid present in the solution is always directly proportional to its mole fraction. Correct or not? Partial pressure of a component or a liquid present in the solution, liquid solution, is directly proportional to mole fraction. It's mole fraction. If it is P1, the mole fraction will be X1. Now remove the proportionality and put a proportionality constant, that is P naught here. So we get here P is equal to P naught mole fraction here. What is P naught here? This is the vapor pressure of pure solvent here. P naught is nothing but vapor pressure of pure solvent. It is pure solvent, pure liquid solvent. That means pure liquid. Write down, because we don't know which solvent, which is liquid. No, pure liquid. P naught is the vapor pressure of pure liquid. Where P is what? Partial pressure of liquid. P is nothing but called partial pressure of liquid in solution. Partial pressure of liquid in solution. In solution. That is called what? pH. So I think everyone knows this law, Raoult's law. Now based on this Raoult's law, okay, we are establishing a relation between the vapor pressure of the solution and mole fraction. Vapor pressure of solvent almost we get, because when you remove the proportionality, we are going to get that one, right? Next, let me see further now. Now, let me see what happened. Lowering of vapor pressure is given by what? This is lowering of vapor pressure or not? Tell me beta. First of all, tell me. It is called lowering of vapor pressure. This one. Delta P is equal to what, beta? Delta P is equal to what I told you? P naught minus P. P naught is nothing but what? Vapor pressure of pure solvent minus vapor pressure of solute. This is called only lowering of vapor pressure. Correct or not?
Yes, sir.
Yes, sir.
What about remaining? Now what I am doing here, delta P1 is nothing but lowering of vapor pressure. Okay, this is what lowering of vapor pressure. Now here, what I am doing here, this is according to Raoult's law, beta. This one, X1 I have taken according to Raoult's law. Isn't it? So why? Because this formula, if you observe here, P1. Now, according to Raoult's law, P1 is equal to what, beta? P1 is equal to what? P naught 1 into mole fraction of 1. Correct or not? Vaishnavi Belgaonkar, present or absent? Vaishnavi Belgaonkar, present or absent? अंदर हैं घर में? Where are you? किचन में हैं और एब्सेंट हैं? वैष्णवी बेलगांवकर, नो रिस्पॉन्स. कोई देखो बेटा है या नहीं है यहां पर ऑनलाइन में? एब्सेंट.
प्रेजेंट है सर.
प्रेजेंट है सर, मगर अंदर हैं, शायद सो रहे हैं बेडरूम में मोबाइल चालू करके. वैष्णवी बेलगांवकर, sleeping in bedroom or otherwise what happened? Watching the class. Right, this is according to what law, beta? Raoult's law. Correct or not? This is what according to Raoult's law. Right? Now, in the place of P1, what I am putting here? This one I am putting here. Now, put this one here. Right. Put this one here. Now, we got again delta P1 is equal to same P what? P1 naught minus P1 into what happened? Mole fraction of X1. Now, take P1 common here. When you take P1 common, what we get, beta? Isn't it? P1 into 1 minus X1. But already you know 1 minus X1 is equal to what? X2. Why? Because mole fraction of 1 plus mole fraction of 2 is equal to 1. Based upon this, 1 minus X1 is equal to what? X2. Now this is equal to what we are going to get based on this delta P1 Delta P is equal to what happened? Mole fraction of what? X2 into P1. So this is the formula we are going to get for what? Only lowering. This is only lowering of vapor pressure. So lowering of vapor pressure is equal to this one is equal to, is it mole fraction into its vapor pressure at pure nature here. P naught means what happened? Pure nature. Now this is what actually P1 is what? Lowering of vapor pressure of solvent it is. Now I am writing over, you want this delta P1, I am writing over, you see. Delta P1, 1 is solvent beta, 2 is solute. Remember this one, solvent indicates 1, solute indicates 2 now here. Right now, delta P1 is equal to lowering of vapor pressure of solvent. How much vapor pressure of solvent is decreased when you add solute to this one. Next, X2 means what? Mole fraction of solute. Mole fraction of solute. Next, P naught 1 means what? Vapor pressure of pure solvent without any solute. Vapor pressure of pure solvent without any solute it is. Now, if you add more amount of solute, what happens beta? When you add more amount of solute to this solvent, this is a solvent which is undergoing something vapor pressure, okay, something like this. When you add more amount of solute, what happens? Vapor pressure will decrease or increase beta? Vapor pressure will decrease or increase when you add more amount of solute?
Decreases.
Decreases.
Now you observe this one, lowering of vapor pressure is directly proportional to X2. X2 is nothing but called mole fraction of solute. That means amount of solute. Mole fraction of solute is nothing but amount of the solute. When I add more amount of solute to the solvent, the vapor pressure of the lowering of vapor pressure will be also more. That means more amount of vapor pressure will be decreased in solvent side. But remember, this is what dilute solution. Don't add huge amount here because this is for dilute solution only. Whatever you are adding, that should be lower amount only. In milligrams only we are adding here. So remember that one, don't add what happened, huge amount here. Why? Because that colligative properties only obeys at dilute conditions. So if I say what happened, the amount of number of moles of solute directly proportional to lowering of vapor pressure, you can't add more amount here. That is having certain limit is there. At that limit, behind that limit only we can add that. Okay, now this is only lowering of vapor pressure. Now let me see relative lowering of vapor pressure now. What is this relative lowering of vapor pressure? See, relative lowering of vapor pressure, when you get whatever the lowering of vapor pressure, I am dividing it what? P naught here. I am dividing it what? P naught here. That is called relative, because this you are relating towards where? The vapor pressure of the pure solvent. For example, the vapor pressure of water. Okay, pure water, pure one. You got something 760 ml, right? At 1 atmosphere. Just assume like that. When you add solute to this one, you got something salt solution. When you add some solute to the water, you got salt solution whose vapor pressure is what? 740 ml. Correct? Now, lowering of vapor pressure, delta P is equal to what? Delta P, lowering of vapor pressure. So, water I am representing this something what? P1 like this. How much it will be? 20. This is lowering of vapor pressure. Or delta P, you can take delta P also, no problem. Next. Now, what is relative lowering of vapor pressure? Now, divide this one with what? P naught. Now, what is P naught beta? 20 by, what is P naught beta? 760. Now, this is called what? Relative lowering of this 20, we are relating towards where? It's a pure solvent vapor pressure only. So, just divide this one with P naught. That is nothing but called relative lowering of vapor pressure. Understood? So, what is this? You see, the ratio of lowering of vapor pressure to the vapor pressure of the pure solvent is called relative lowering of vapor pressure. I am again repeating. The lowering of vapor pressure delta P to vapor pressure of the pure solvent is called what? Relative lowering of vapor pressure. Isn't it? Now, let me see what happened. That again we just do some more simplification to this formula, because already we got delta P is equal to how much we got beta, this one. Okay. Now let me do one thing here again with previous formula. Delta, the previous formula we are taking, delta P1 is equal to mole fraction of 2 into P naught, correct or not? Now what I am doing here, this is when I shift here, the formula we are going to get delta P1 by P naught, that is equal to mole fraction of solute. Now this we are calling as what beta? Relative lowering of vapor pressure. Now based on this we can write relative lowering of vapor pressure is always equal to mole fraction of solute, correct or not? This formula you got. Now relative lowering of vapor pressure is always equal to what? Mole fraction of solute. Now this is the formula. What is relative lowering of vapor pressure? Delta P. Delta P. Or P naught minus P. P naught minus P. P1 is nothing but solvent it is. Divided by P naught. This is called lowering of vapor pressure, and this is called what? Relative lowering of vapor pressure. These two are called relative lowering of vapor pressure. Now what is P naught minus P1? This is called what? Delta P, lowering of vapor pressure. So these formulas you have to remember like this, because in examination they may say what data they may directly give the relative lowering of vapor pressure is this much like that. That means P naught minus P divided by P naught is equal to product the data action. Right? Now mole fraction of solute is equal to what beta? What is the formula for mole fraction of solute? Again I will write the mole fraction of solute formula like this. I will write. Now mole fraction of solute is always equal to, I can write P naught minus P1 by P naught is equal to mole fraction of solute is equal to number of solute particles divided by number of moles of solvent plus solute particle. Now this is what one more formula we can generate, because this is nothing but mole fraction of what? Solute actually. Now number of moles equal to what beta? Number of moles equal to what beta? N2 is equal to what I can write here? Weight of solute divided by molar mass of solute here. Okay, weight of solute divided by molar mass of solute here. Similarly, N1 is equal to weight of solvent by molar mass of solvent. Now when you substitute this one in this formula, what we get beta? P naught minus P1 by P naught is equal to, now N2 is equal to what? You can take this formula I am taking, W2 by M2 divided by again N1. N1 is equal to what? W1 by M1. Here I have written M1 it is, right? We can take here M1. Plus what happened again N2. N2 is again what? W2 by M2. But which type of solution beta? These are dilute solutions. These are what actually extremely dilute solution. In dilute solution, the amount of solute will be how much beta? Will be negligible or considerable? The amount of solute in the dilute solution is negligible or considerable?
Negligible.
Negligible. But for example, if I put something what? 0.005 moles I have added. Just imagine like that. Okay. N1 is something what? 1.2 moles. N2 is something again same value, 0.005. If I add this one, how much value we get here? 0.005 divided by 1.20, isn't it? And what happened? 5 lines. Okay. Now the difference between the 1.2 and 1.205 is not much difference. So that is the reason what we'll do here. This is the dilute solution. So this is the dilute solution. Therefore, neglect this value. Neglect this value. Now in this case, what formula we can write? P naught minus P1 divided by P naught is equal to, okay, what we can write? N2 by N1 we can write. N2 means already you know, and N1 means already you know, this one. N2 by N1 will be like this. So finally, I am writing this formula over here. P naught minus P1 by P naught is equal to W2 by M2, weight of the solute by molar mass of the solute. Next what happened? Molar mass of the solvent by weight of the solvent. This is the final formula will be useful for our examination point of view. This is the formula we are using. So all of you remember this formula. P naught minus P1 by P naught is equal to W2 by M2 into M1 by W. This is very important formula. Right? Next, we'll do some problems over this one. This already we have discussed everything. No need to again now directly formula for this one. This is the formula we got actually. If I show what happened, you may get confused like this. So that is the reason I've written like that. So again, I'm writing same thing. P naught minus P1 by P naught is equal to weight of the solute divided by molar mass of the solute. Molar mass of the solvent by weight of the solvent. Again, I'm writing over here. What is this? P naught means what? Vapor pressure of pure solvent. Vapor pressure of pure solvent. Now, what is P1? Vapor pressure of solution. Vapor pressure of solution. Right? Next, W2 is equal to what? Weight of solute. Weight of solute. Next, M2 is nothing but what? Molar mass of solute. Molar mass of, that means molecular weight of solute. 2 means solute beta, 1 means solvent. Next, M1 is equal to molar mass, molecular weight of solvent. Molar mass of solvent. And finally, W1 is equal to weight of solvent. Weight of solvent. Now, by using these things, we can derive. Now, when you send this W2, everything over here, what happened here? When you send everything over here, what we can write here? P naught minus P1 into M2 into W1 divided by M1. This is equal to what here? W. Don't remember this formula, leave it this one. If you remember this one, you can get everything. From this equation, you can get this equation, right? Now, we'll do one problem over here. Already I told you, the conditions compulsory, it should be dilute solution. Whatever the colligative properties for only dilute solution, and the solute must be non-volatile and the solvent must be volatile, and solute does not undergo any change in molecular state like dissociation, annihilation, association. That means I will explain this one later. This one I will explain later. Finally, I will explain this one after completion of four colligative properties. Okay, this is for ideal solution that already definitely if it is obeying Raoult's law, what happened? Definitely it's for ideal solution. Can you give the answer for this one, beta? Relative lowering of pressure is equal to
B.
mole fraction of the solute, beta, but not solvent. Always you take solute only, right? Now let me take a problem, beta. Now, so in examinations you may get problem from this compulsory. 90% of choice you may get problems from the colligative properties. 90% choices are there. Now here, let me take the data first of all. A vapor pressure of benzene. That means it is a pure solvent. P naught is given, right? A non-volatile solute, its weight, that means what happened? W2 is given. Solute weight is given. When added to 9 grams of benzene, this is nothing but weight of the solvent here. Weight of the solvent, weight of the solute, and vapor pressure of the pure solvent it is. Next, molar mass also given 78. This one will be M1. M1 it is. Then the vapor pressure of the solution is, this one also given. Vapor pressure of solution means what? P1 also given. P1 also given. P1 is given. Now find the molar mass of the solid. They are asking what W2 they are asking. They are asking the W2. Right? So we take all this data now. You see, we have taken P naught value. You have taken weight of the solute. You have taken molar mass of the solvent. You have taken the weight of solvent. Okay. Now what they are asking here? Vapor pressure of the solution P1 it is, and by applying this formula, this is the formula only, no? P naught 1 minus P1. This one you don't need to take this one, leave it this one. Okay, no need to take this one to avoid that one. Otherwise, you can take also, no problem, beta. Nothing difference is there. Now substitute that P naught value, how much, beta? Here only I will substitute everything. I will write the formula and I will substitute P naught minus P1, okay, divided by P naught is equal to weight of the solute by 2 molar mass of the solute. Again, molar mass of the solvent by weight of the solvent. Now, P naught is how much beta यहाँ पर? 0.85 minus. P1 is equal to how much they given? 0.845 it is divided by. P naught again I am taking here 0.85 here is equal to weight of the solute we need to calculate here. Molar mass of the solute. How much they given?
Weight of the solute is given 0.5 gram.
Okay, but weight is given. Sorry, no, this one is what? 0.5 gram. We are calculating molar mass of the solute here. Next, molar mass of the solvent is 78. Weight of the solvent is given how much here? 13 grams. Okay. Now you can do this formula by 13 1 9 2 here. This will get a 0.1 here. 0.1 M2 here. Now you send this one, you will get the answer like this. 200 grams. 200 is the molar mass of what? That's solute here. Okay, in this way you can do the problems. Very simple it is. Now before starting the next one, next colligative property, that is elevation of boiling point. You must understand what is the meaning of boiling point first of all. Temperature at which vapor pressure of liquid is equal to atmosphere vapor pressure, and that temperature is called what? A normal boiling point, or simply we can call boiling point. So I have taken the water beta. I have taken some water here. Now here the atmosphere pressure is 760 mm. Correct? 1 atmosphere. That is equal to 760. And the vapor pressure of the liquid also 760. Then at what temperature is happening? At what temperature the vapor pressure of the water and the vapor pressure of the atmosphere is getting same? At that temperature I have taken as a boiling point, that is 100 degrees Celsius. I can say at 100 degrees Celsius, the vapor pressure of water is always equal to atmosphere vapor pressure. Right? So the boiling point is 100 degrees Celsius. Next, we will start what happened. Generally, thermometer is used to measure the temperature. Correct? So different liquids will have different boiling point because they will have intermolecular forces will be different. Actually. So boiling point of water will be 373.15, nothing but 100 degrees Celsius here. And for alcohol, it will be 78.1 degrees Celsius. Let me take here what happened, a diagram. Before the diagram also, first of all, I will explain this elevation of boiling point, then I will take the diagram. Let me see first of all, what is this elevation of boiling point. Get what happened. Space here. Here I will type in this one. Now, first of all, again I am taking same experiment beta. I have taken water over here. I have taken here water. I have taken some amount of water. Now, before that, before any addition of solute, what happened? This is getting evaporated. So we got some vapors here. Now it will have a vapor pressure. Because of this vapor, they are getting a vapor pressure. So that is nothing but what? P naught. Okay. But when you add some solute, to this one, some of the surface is occupied by the solute, so the less vapor we are going to get. We are going to get less vapor pressure here. When you add some solute, before addition of solute, and here it is what? After addition of solute. Now vapor pressure is decreased or not? Now, what is the relation between vapor pressure and boiling point? Anybody? Vaishnavi K, what is the relation between the vapor pressure and the boiling point? Inversely or directly? Vaishnavi K. The relation between vapor pressure and boiling point is directly or inversely? Vaishnavi K. Absent? Vaishnavi VH?
So directly.
Directly proportional.
Yes, sir.
For example, isn't it? I have taken water. Here I have taken benzene. I am saying benzene boiling point is 78 degrees Celsius. Correct? Water is having 100 degrees Celsius. Now, which is having more boiling point, beta? Among these two, which is having more boiling point only? These boiling point values are written. Tell me, beta, which is having more boiling point?
Water.
Water.
Is having more boiling point. Now, water is having more boiling point. Now, which will undergo more evaporation? Benzene or water?
Water.
More evaporation. Benzene.
Benzene.
Then petrol I have taken. Petrol. A real example I will take. And I am taking water. Now tell me, beta, if you put on in atmosphere, which will undergo evaporation? Petrol or water?
Petrol.
Now, whichever undergo easily evaporation. Petrol undergo easily evaporation. Easily evaporation. Now whichever undergo easily evaporation, they easily convert into vapor. They easily convert into vapor. And this is very difficult to convert into vapor. Difficult to convert into vapor. Now, which will have more vapor pressure, petrol or water? Now, tell me. Which will have more vapor pressure, petrol or water? Which is forming more vapor, petrol or water?
Petrol.
When petrol is forming more vapor, definitely it will have more vapor pressure. Correct? When water can form less vapor, definitely water can form less vapor pressure. Now tell me, boiling point of water is 100 degrees Celsius, but vapor pressure is less. Boiling point of petrol is what? Where was something what happened? 20 degrees Celsius, something 25 degrees Celsius, something. It has more vapor pressure. So what I can write here? Directly proportional or inversely proportional?
Inversely proportional.
Inversely proportional.
Inversely.
Vapor pressure always inversely proportional to boiling point. Now, after addition of the solute, the boiling point of this solvent is increased or decreased? After addition of solute, this boiling point of this solution increased or decreased, beta?
Increase.
Increased. Why? Because when you add solute to the water, water vapor pressure decreased. Correct or not? When you add some solute to the water, water vapor pressure is decreased. Previous concept. When vapor pressure is decreasing, boiling point what happened here? Increases. So what is the colligative property we are discussing here? Elevation of boiling point. Elevation means increasing. That means when you add some solute to the water, boiling point will increases, vapor pressure will decreases. If you remember this one, it will be easy for this one. Where? This one. Vapor pressure, this point. Vapor pressure is inversely proportional to boiling point. In the previous case, lowering of vapor pressure, now elevation of boiling point. So when you add some solute to the solvent, its boiling point always will be increases. You see this diagram here. Now here actually its boiling point is here. Before addition of the solute. You didn't add any solute. This is the boiling point of the water, solvent it is. Now when you add solute to this one, you got solution here. You got solution here. Now boiling point is how much here? Increased here. Isn't it? Understood, beta? When you add some solute, its boiling point what happened? Increased. Of course, vapor pressure definitely what happened? That will decreases. Because we are not discussing now here vapor pressure. We are discussing about what? Boiling point. So based upon this, what we can write here? The vapor pressure of an aqueous solution of sucrose is less than 1 pint atmosphere at 373.15 Kelvin temperature. Okay. The vapor pressure is less, but boiling point will be what here? More actually. Now let me take some formulas, everything I will write here. Directly I will write everything. Now, del T naught will be the boiling point of pure solvent beta. Whenever you get naught, that is nothing but pure beta. Boiling point of the pure solvent. Okay. Now TB is the boiling point of the solution. Now what I can write? Elevation of boiling point. Delta TB is equal to elevation of boiling point is equal to what I can write? What I can write, beta? Elevation of boiling point will be always equal to what I can write? Boiling point of solution minus boiling point of the solvent. This we can write. boiling point of the solute minus or solution minus boiling point of the solvent. So this is the formula. This is the formula we can write here. Correct or not? This is called what? Elevation of boiling point. Now elevation of boiling point also depends upon number of moles of the solute. Correct or not? Because if we add more amount of solute, the boiling point is further increasing because of lowering of vapor pressure. So based upon this, what I can write? Delta TB is equal to elevation of boiling point here. So based on this, what I can write here? The formula I am writing here. Now, if I take more amount of what solute particle, then I get what? More amount of what? Elevation of boiling point. So because of this, what I am writing? Delta TB. Now I can write directly proportional to molality now. Now, why I have taken molality? This is has certain some type of formula is there. I am applying that one. All of you please observe here. Now, molality is equal. What is the formula? Anybody? Number of solute particles. Otherwise, mole fraction of solute. Write down. Sorry, write down the mole fraction of solute. What is the formula beta? W2 by M2 into what we are writing? Divided by M1 by W1. This is only we written, no, because if it is dilute solution. For the dilute solution, I have written this one only for, this is for dilute solution. Because that numerator, we are having solute particle, but in the denominator, we are removing that one. Correct or not, beta?
Yes, sir. Yes, sir.
Now multiply this one with 1000 and 1000 here. Anything happens if I take? Nothing happens, no? Now, next I will take what?
Yes, sir.
W by M2 into M1 by, not M1, 1000 by W1 into, isn't it? M1 divided by 1000. Shall I write like this formula? Any wrong is there in this case?
No, sir.
What is this formula? Which formula it is?
Molality.
Molality formula. So in the place of this one, I can write mole fraction of the solute X2 is equal to molality into, isn't it? M1 by 1000. Now what is M1 beta? Molecular weight of solvent. Molecular weight of solvent divided by 1000. So I can put in the place of mole fraction of the solute, I can put molarity now. That is the reason I am putting molarity here. Now I have taken Kb here. What is Kb? It's a proportionality constant. In this Kb, we can write here M1 also. Every solvent will have different K value. I will show that one. Water will have different K value. Benzene will have different K value. CCl4 will have different K value. Why? Because this M1 will be constant for what? All the solvents. For water, it will be 18. For benzene, it will be 78. Like that, what happened? This M1 depends upon the molecule. Therefore, these values will be taken in terms of Kb here. Instead of taking what M1000, I am removing the proportionality and putting what here? Kb. Kb is nothing but here proportionality constant can be called elevation, molar elevation constant. We can call this one. Kb is called what? Molar elevation constant, or otherwise also called what? Boiling point elevation constant. So what we can call here? Molar elevation constant. We can call this one, or we can call ebullioscopic constant. We can call, or we can call boiling point elevation constant. We can. Now, based on this, what will be the formula beta? M is equal to molarity of the solution, and Kb. What is Kb now here? Kb is equal to what I can write beta? Delta Tb divided by molality. Now, what are the units for delta Tb beta? Units for the temperature. Temperature units what? Kelvin, capital K. Molality, kg or gram.
kg per mole.
Units. If I take SI units, kg per, sorry. If I take SI units, what happen? Mole per kg. Mole per kg. But send this kg over here. What we get here? Kelvin into kg into what happened? Per mole. This is the units. Now this is very, very important in examination point of view. Following which option is correct? Or otherwise, following which option is correct for what? units for elevation of constant, units for molar elevation of constant, otherwise units for ebullioscopic constant. Now, what are the units here? For temperature, Kelvin. For molality, mole per kg. For molality, what is the units, beta? Mole per kg. For this one, mole per kg. For this one, temperature, K actually. So this is very important question you may get in examination. Right? This is called molar elevation constant. Now let me take formula again. What will be the formula again? I am writing here. This will be the molarity formula. So I am writing the formula, shooting everything. So this is the formula we are going to get. If you don't understand, I will write again later. Delta TB is equal to boiling point of solution, boiling point of solution minus boiling point of water. Be right down here. Be right down. Boiling point of water. Boiling point of solution minus boiling point of water. This is always equal to Kb, elevation of boiling point, into molality formula. What is molality formula? Weight of solute divided by molecular weight of solute into 1000 by weight of solvent. Now this is the formula we use for calculating the elevation of boiling point. Now from this formula we can write M2 also. We can get this M2. How we get this M2? By sending this value over here and this value over here, we get this formula. So with this, what happened? I have completed elevation of boiling point also, right? Elevation of boiling point also we can. Now let me take a problem beta in this case. Now what they given? Weight of the glucose, weight of the solute, W2 is given here. This one is a W2 here. Now weight of the water, weight of the solvent is given. Next, at what temperature water boils? 1.013 bar, Kb is given 0.52. Kb is given 0.5. So they are asking at what temperature that water is boils here. They are asking what happened? The boiling point of the solution they are asking. The boiling point of the solution they are asking. When you add 18 grams of glucose to the 1 kg of water, what is the boiling point of the solution they are asking? So I will write what I call, first of all, weight of the solute is what? 18 grams. Weight of the solvent is what? 1000 grams. Next. Molarity, leave it this one. We'll do that one. Molarity will do that later actually. Now, formula I am writing over here, delta TB. Delta TB is equal to what actually, beta? Boiling point of solution minus boiling point of the solvent is equal to Kb into molarity formula, weight of solute by molecular weight of solute into 1000 by weight of the solvent. Now we are calculating boiling point of the solution. Now boiling point of water will be what? What beta? Boiling point of water. T0 will be, they don't give T0 value beta. Boiling point of water, you know that one. How much it is?
100.
3.15. Don't take in degrees Celsius. Always in that I have taken Kelvin only. Kb value, I think they given how much beta? 0.52. 0.52. Now weight of the solute is how much? 18 grams. Take here 18 grams. Molar mass of glucose will be 180 beta into 1000. Now weight of the solvent is how much given? 1 kg means 1000 you take. Now 1000 get cancelled. 18 ones are 18 tens are here. So remaining here how much we are going to get here? 0.52 divided by 10 is equal to how much it will be? 0.052. Now TB is equal to 373.15 plus 0.052 is equal to what you are going to get. Whatever you get, that will be the answer. The boiling point of the solution. So this is about the elevation of boiling point. This is about the elevation of boiling point, isn't it? So you will get something 373.2. This is the values in something 373.2 you are going to get.
Sir?
Bola beta.
Sir, Kb is a constant, then it has constant value for all the solvents.
I told you na beta. Just now I told you what here if you observe here. Just I'm writing it. In this formula, if you observe, Actually, delta TB is directly proportional to what? Mole fraction of solute. Correct or not, beta?
Yes, sir.
But mole fraction of solute I have converted into molality. How? Like this, no? How? Molality into 1000 by molar mass of solvent. Correct or not? Just now we have done this formula. Correct or not? This one is
Yes, sir.
correct. Now here, this m value, sorry, not reversely I have written, I think. Reversely. M1 by 1000 actually. No, 1000 by M1 only, correct. 1000 by M1. Right? Now this value depend upon what actually? Molar mass of the solvent here. That means what happened? When you change the solvent, the Kb value also changes. Different, isn't it? Solvents will have different Kb value. For water, it will be 0.52. For benzene, it may be different here. Everything will be different better. Because we have derived this molality from the mole fraction. In mole fraction, we have compulsory molar mass of solvent is there. Now, molar mass of solvent we didn't include in this one. We didn't taken in this molality here. So, molar what solvent will comes from where? Kb value here. So, when you change the solvent, Kb value also will change. In textbook, you see beta, different solvents that they given, different Kb values. So check that one. You can check that one also.
Yes, sir.
Right, elevation of boiling point is completed beta. Next will be what? Depression freezing point will be there and osmotic pressure will be there. Two more colligative properties are there. Depression and freezing point. Just I will explain depression freezing point just with what? Example with what? Just now taken elevation of boiling point. So, see beta, they want to discuss this class in next, otherwise shall I continue this one? It takes 5 minutes. You see beta here. For water, if you observe, elevation of boiling point 0.52. For ethanol, elevation of boiling point 1 point. That means the solvent, when you change, what happened? We get different Kb values. So Kb value they will give in examination. Don't need to remember this one. Understood? Now one thing I will do here, for depression freezing point, definitely what happened? When you add some solute, the freezing point will decreases better. Boiling point will increases, but when you add some solute to the solvent, freezing point will decreases because freezing point is directly proportional to vapor pressure here. So definitely what formula we are going to get better here? For depression freezing point, what type of formula we are going to get here? Delta TF is equal to freezing point of solvent minus freezing point of solution. This we are going to get. Again, the formula will be like this. Delta TF is equal to T naught F minus TF is equal to, same formula, weight of the solute divided by molar mass of the solute into, isn't it, 1000 by, isn't it, 1000 by what is molar mass of solvent into what happened? Kf I have taken here. In the place of Kb, I have taken here Kf. What is Kf? Molar depression freezing point or cryoscopic point, we can call this one. Okay, that is
constant.
depression constant. This is depression constant. That is called what? Ebullioscopic constant. This is called cryoscopic constant. That is called molar elevation constant. This is molar depression constant. Same formula, but here we are changing difference we are going to get. In that case, we got TB minus T naught B beta. Reverse we got here. Reverse we got. In freezing point and boiling point, they were reverse actually. First you have to solvent, you have to take. For freezing, first you have to take solvent. For boiling, first you have to take solution. Same formula we get actually. When you do one problem, what happened will be very simple. This one problem I have to take here. Weight of the solute is given. Weight of the solute is given here. Weight of the solute is given. And what happened? Weight of the solvent is given. Kf is given. They're asking freezing point, depression constant they're asking. Kf they're asking. The freezing point of the solution they're asking. So in this case, what happened? Easily we can find out, isn't it, by using this formula actually. Okay, let me discuss this one tomorrow. Tomorrow means of day after tomorrow we'll discuss this one. So still one topic is small topic is left, that one, that is called osmotic pressure. That is a small topic only. Only problems are left over beta. Only problems are there. And that last topic called, what is the last topic? One half factor is not there beta. In your syllabus, one factor is not there. So tomorrow, I mean on Monday we'll discuss problems and small topic about the osmotic pressure. So Monday onwards, we'll do the revision only. After complete, I will complete this osmotic pressure on Monday. And we do the problems, remaining problems, whatever problems are there in the textbook, present in the textbook, we'll discuss from Monday onwards. Any doubts?